Welcome back. Let's now go over the solutions for the NumPy and images assessment. I'm going to open up the notebook in the Jupyter Lab now. All right, here I have the assessment open. Let's go ahead and start by completing tasks in bold below. So importing NumPy, that's pretty easy. You can either just say import NumPy, but typically you'll say import NumPy as NP. That way you don't need to call NumPy, just call NP each time. And then the next one is create a 5x5 array where every number is a 10. So there's actually lots of ways to do this. But one easy way is to say NP1s, and then we want a 5x5 for the shape. And if you notice, this array itself is just going to be a bunch of ones. So if I say just array, that's 5x5 of ones. So what I can do is multiply this by 10, and then on an element by element basis, everything is going to get multiplied by 10. So you can do element by element operations on every element in an array. And we didn't explicitly mention that in the lecture, but we gave you a hint in the previous lecture on how to do that. And this goes for anything. So if you wanted to say array divided by 2, then everything becomes 0.5. Since you have all ones, you can divide it by 2. So we'll do this from time to time as far as quickly building up arrays of a particular digit. So the ones that we're going to be using a lot is if we wanted everything to be max color, we could just say, give me an array of 255. Or we could use zeros for the opposite. Okay, so that's creating a 5x5 array. Then we wanted to run the cell below to create an array of random numbers and see if you can figure out how it works. We mentioned this in the actual previous lectures on NumPy, but essentially, in case you didn't grasp it then, what this is doing is setting a random seed, and this number, 101, it's actually arbitrary, so you can choose any number you want. What you want to do is be consistent with your number choice. That way, when you actually generate random numbers, you generate the same random numbers that the given seed provides. And then this line creates an array of random numbers. So what it does is it says, from NumPy, grab the random library, and then grab the random integer, or randint function. And then if you do Shift-Tab here, it'll tell you that it takes in a low, a high, and then a size. So all this is doing is it's going to return random numbers drawn from a range of 0 up to, but not including 100, and then format them in a size a 5x5. So if I run this and then check out the array, then I have these 5x5 random numbers. And if you actually run this and set the seed to 101, every single time you create these random numbers, you'll notice that you get the same random numbers. If you change this to a different value, like 42, then you'll get a different set of random numbers. But you would get these same random numbers every time you run this. So notice how the in cell in the number is changing. So that's how the seed actually works. So we'll choose the default, or it's actually not a default, but we'll choose my value, 101. That way you get the same values I do. So then the question was, what are the largest and smallest values in the array? Well, in that case, all we need to do is say array max and array min. Pretty straightforward there. Okay, then we wanted to use the Python imaging library and matplotlib to read and display that puppy image. So this is actually exactly the same thing we did in the lecture. So a couple ways we can do this. One way is to say import matplotlib. In fact, let me comment this out and just get rid of that picture so we can see this in full. So we're going to say import matplotlib.pyplot as PLT. So that's going to allow us to have plotting functionality. Since we want things inline in the notebook, we're going to say matplotlib inline. And as I mentioned before, the newest versions of Jupyter Lab and Jupyter Notebook actually do this by default, so it may work even if you don't add that line in. But if you're running an older version of Jupyter, probably a good idea. Then we're going to say from Python imaging library, import that image function. And then this image function, remember, it can actually read in JPEGs and PNGs directly. So what we're going to do is from our data folder, so depending on where your data folder actually is, you're going to want to say image.open and then provide the file path. So in my case, the way I have things organized right now is I actually have the data folder right here in the same directory as this particular notebook. So there's my data folder with all the JPEGs and image files, etc. So I'm just going to link to it here. So in that case, we're just going to say data/00, and I should be able to tab autocomplete this. Okay. So if you're not able to tab autocomplete, that's probably a good sign that you're actually not providing the same directory or correct directory. And then after that, if I were to run this, I could just say pick, and the Jupyter Lab or Jupyter Notebook will automatically show the picture of the puppy. Okay, now remember, this is actually still kind of the specialized image file. So if I check the type of pick, it's a JPEG image file. Now I want to convert the image to a NumPy array, and then maybe we can check the shape to confirm that it's actually a NumPy array. It's actually pretty straightforward. We did this in the lecture. I can just say array is equal to NP as array, and then pass in the picture. And now if I check the type of this array, I get NumPy in the array, and then I can also check a shape. Notice it's 1300 by 1950, and it has 3 color channels. So the final task is using slicing to set the red and green channels of the picture to 0. Then use imshow to show the isolated blue channel. So if I were to say plt imshow on that particular array, it shows the puppy and it shows all 3 channels. So let's actually then, we're going to create a copy of this. So we're going to say my copy is equal to array copy, and then we can kind of mess around and edit the copy, and then we can still compare it to the original array. Okay, so what's our actual task here? We want to zero out red and green. So these images, the way NumPy is reading them in, and the way the Python image library is reading them in right now, they go in the order of red is the first layer, green is the second layer, and then blue is that third layer. So what I want to do is grab the 0 index layer and the 1 index layer, and then set them all to 0. So we'll say my copy, and I want to grab all the pixels in the x and y dimension, or the width and height, for that first channel in that 0 layer. And then I'll set those all to 0. Okay, so let's go ahead and then show plt imshow my copy and see what that looks like. Okay, so you can already see it's already looking a little weird, and that makes sense because now the only channels that are left in this image to show are the blue and green channels, which is why everything looks a little kind of aqua-ish color. So only green and blues are allowed now. Now let's go ahead and zero out. So we just did the red channel. So this is red to 0. Now let's turn the green to 0. Green to 0. So we'll say my copy. We're going to have everything, all the rows and columns in the second channel at index 1 because it goes red, green, blue. And then we'll set those to 0 as well. And now when I show it, now only the blue channels remain. And you'll notice that there's actually not a lot of blue in this image, particularly around the dog's ears, because if you saw the dog's ears, as we mentioned before, they're quite red. So there's actually not a lot of blue coloring in it, which is why there's pretty dark values when we're only isolating the blue channel. All right, so that's it. As far as this section of the course, the main things you need to understand is the ability to create arrays of a single value. So random arrays, we really won't be dealing with it at all for the rest of the course, but what you really should feel comfortable with is creating NP1s and especially NP0s as well. So if you can create NP1s and NP0s of any shape, then that's all you need to understand there. Don't worry too much about understanding PIL and opening images this way. When we move on to OpenCV, we're really just going to be not using these 2 lines of code anymore. Instead, we'll be using a special function from OpenCV. But I did want to show you this so you can directly go from a JPEG straight to a NumPy array. And then finally, the thing you should understand here is that color images come in 3 channels, red, green, and blue. And then later on in some more advanced sections, we'll talk about different color mappings that go beyond just red, green, and blue color coding. All right, I hope that assessment was useful to you. It should have been pretty straightforward given how well it matched the lectures. Coming up next, we're going to begin talking about OpenCV, Open Computer Vision Library. We'll see you there.